Welcome to LabMinutes.com. In this video, we will be talking about Network Address Translation, or NAT. In order to understand NAT, you need to understand the concept of inside and outside network. Inside usually being a more secure side representing a network you want to protect. There are different types of NAT. Some allows you to only access the outside resources, and some allows inside resources exposed to the outside. In our lab, we will be looking at various types of NAT in their most basic form. So as shown in the diagram, we'll be looking at static NAT, dynamic NAT, PAT or port address translation, and conditional NAT. So let's start with our first NAT scenario, which is static NAT. Just to show you what we have set up, we have a switch 1 with 2 loopback interface, loopback 0 and loopback 1. Actually, let me update loopback 1 IP to 172.16.32.35, so it's not right next to the .32. And switch 1 has a static default route pointing towards R1. On R1, we have 2 interfaces, with fast00 being the inside and fast01 being the outside. And we're going to quickly add a static route pointing to the whole 32 subnet, pointing towards switch 1. In R2, we just have one interface right now on the outside. Okay. So first, let's look at some global NAT commands. The first command we will do is NAT translation. And here, you can see there's all type of different types of timeouts value that you can define. So first one we're going to use is timeout. And this particular command is for dynamic NAT that we will use later on, as specified right here in the description, dynamic NAT translation timeout. We're going to choose 30 seconds. Next, we're going to do a translation, just to give you an example, TCP timeout, usually for PAT, and we're going to pick 60 seconds. Another timeout that we're going to do is the UDP, and here we do 5 seconds. Next, we're going to specify the maximum number of NATs allowed on the router, and there's different options you can do. You can do all hosts by IP of the host, or you can do by VRF if you do a VRF. But we're going to specify global value 16384. Next, we're going to go under fast00 and specify is a NAT inside. Next, we go to fast01 and specify as the outside interface. Okay. So in our first scenario, we would do a one-to-one static NAT, converting or translating a .32 32.32 to 1.32. So the command is IPNet inside, because we're coming in from the inside, source static, and the inside local IP. Here is 32.32 to inside global. Global being the IP where the world sees you. So 111.32 in this case. And we're just gonna go with that. Okay. So next we're gonna do some test ping. So I'm gonna enable debug IP as CMP on R2, and we're gonna do debug IPNet on R1. And on switch 1, we're going to do ping 1.1.1.1, sourcing from loopback 0. Okay, the ping succeeded, and the debug on R2, you can see R2 sees the ping coming from 1.32, which is our NAT IP, and on R1, our NAT debug messages also shows the translation that was performed. If you quickly go into Show IP NAT Translation, you can also see the translated IP in this table as well. Okay, just to show you that since we are translating or NATing it to the IP that's local to the outside subnet, if you do show ARP, you can see the ARP entry for the .32 is actually the same MAC address as the .252. Okay. So what it means is the R1 actually reply the ARP request on the switch 1 behalf, or in other words, it's acting as a Proxy-ARP. So let's prove that for a little bit. So no, I'll clear the ARP. Okay. The C32 shows up immediately. If you do debug ARP and do clear ARP again, and you can see R2 sends an ARP request for destination.32, and the ARP replies was sent back by the switch with the switch MAC address. Okay. So going back to the command that we had, or we just did, if you look at the option, there's an option called no alias, and basically what it does is it tells the router not to perform Proxy-ARP for that particular NAT IP. So let's try that. So now we do no alias on R2, clear it. And again, R2 is trying to ARP the 111.32 IP, but this time there's no reply. And if we show ARP, or actually trying to ping .32, again it's just trying to send an ARP request. Nothing came back. It showed up as incomplete, and that's because we told R1 not to reply the ARP. So let's put that. So let's delete that. Okay. Actually, let's put that back. And ping 132. And now we can ping successfully. Okay, the next type of NAT we're going to do is still static NAT, but this time instead of specifying an individual host, we're going to do by subnet. So let's delete that. So we're going to be mapping a 32.32 subnet to a 1.64 subnet. So you can see it doesn't really have to be a one-to-one direct map. It just has to be the whole subnet to subnet map. Inside source, static, and here we do network, and we're going to do 172.16.32.32, and we're going to NAT it to 111.64. We're going to do a subnet of 32 hosts, so /27, enter. Okay, now go to switch 1, perform the ping one more time, succeeded right away, and now it's showing up as 111.64. Okay. If you now go and source it with loopback 1, which is a .35, looks like the diagram is incorrect here, it should be .35, and the R2C is as .67. Again, that's incorrect. So .35 is 3 IPs away from .32. That's why it was showing up as .67, and that's also 3 IPs away from 64. Okay. If you do show IP net translation, tells you right here 32 goes to 64 and 35 goes to 67. Okay. Now let's move on to the next one, which is dynamic NAT. Let's remove this guy. Okay. So for dynamic NAT, we're going to be creating a pool of IP. So the command is IP NAT pool, and we'll give it a name, NAT pool. And next you need to define the range of IPs you want to allow to be used for the NAT, and it doesn't really have to fall within the subnet boundary. It's just, it can be basically any arbitrary value. So I'm just going to do, let's say, between 20 and 50. So the prefix length 24. Okay. Next, we're going to create access list to match an interesting traffic. So here we're going to call ACL server, and we're going to be matching the whole .32 subnet going to anything. Okay, so IPNet insight source list ACL server, then pool, and we have a NAT pool created. Okay, going back to switch 1, do a ping from loopback. Let's try start from loopback 1 this time. So ping. Oops, it's failing. So if you jump to R2, you can see the IP came through correctly, which is 222.20, and that's the first available NATed IP. But the reason the ping is failing because R2 right now does not know how to get to 2.2.2 network. So what we need to do is create a route pointing back to 111.252, and we can try to ping again, and now succeeded. Okay, now if we move on to using loopback 0 and ping, so went through, and it picked up the next available IP from the pool, which is .21. So you can see the IP was not pre-assigned. It's just based on first come, first served to pick the IP from the pool. Okay. Just to show you one nice little trick, if you go back to our IPNAT command and look at the option, at the end there's an option called, let's see, when you create the IPNet pool rather, there's an option called add route. So what it does, well, it says being used, so let's remove that real quick. Okay, put that back. So what it does, if you do show IP route, it installs a static route pointing to NVI 0 interface in the routing table. So for example, what we did before with R2, we had to manually add a static route pointing to that IP. If R1 and R2 were to run the dynamic routing protocol, we can easily redistribute that static route and have that route automatically advertised to R2. So R2 will be learning that subnet and knows exactly how to reach that particular subnet. Okay, so that's the add route option at the end of IP NAT pool. Okay, so that was dynamic NAT. Next, we're going to do port address translation. I forgot to mention that when you do static NAT or dynamic NAT, the inside or IP on the inside can be reached from the outside. So if you were to have a server that needs to be accessed from outside, you would probably need to use static NAT. On the other hand, even though dynamic NAT allows the resources on the inside access from the outside, since the IP is not really predictable because it will grab the first available IP, is not very much useful as far as having it assigned to a static server. But for any client running an application that requires a one-to-one NAT, or it doesn't really work that it doesn't like the port to be translated as it performed in the PAT, then you would need to use dynamic NAT. Okay, now we're going to look at the PAT. The PAT is basically it's going to have both IP and port translated as shown in this diagram here. I guess all of my IPs in this diagram is kind of incorrect. Out of 33 should be 35. I will fix that before I upload it to the website. Okay, so let's remove NAT configuration we did so far. Okay. Okay, so now we're going to do IP NAT insight source list ACL server interface. Actually, you can either NAT it or PAT it to any IP of your choice by defining it in the pool. But you can also use the interface IP. In this case, it's FAT01. And don't forget overload. Overload, make sure it's a port address translation. Now, this time, let's try telnet to 1.1.1.1. Source will look back 0. You can see you get a prompt, and now we're in R2. If you do who, R2 is seeing the telnet session coming from 1.1.1.2.5.2, which is the R1 outside interface. So we do show IP NAT translation. You can see the actual port number. In this case, they are the same because the router was trying to honor your request, and if that port is not already used, it would just let it through untranslated. But if it's already used, it will be translated to something else that's available. So let's try to do verbose. If you do show IP NAT translation verbose, you can see it shows you the timeout value. Looks like it's already timed out. Okay, let's try that again. Okay, let's see, it start counting down at 60 because when we at the start of our lab, we specify the TCP timeout to be 60 seconds. Okay, so now let's exit and do telnet, but this time sourcing from loopback 1. Again, you are able to hit R2 no problem. And when you do who, this also gets translated to the exact same IP. Okay, so that's the first session with .32, and that's the second session with .35. They both get translated to the same IP. Okay, the last scenario that we're going to try is conditional NAT. Conditional NAT is basically a NAT that perform based on the condition that you define. Usually the condition is the destination IP. So what you can do is you can have the same IP NATed to a different IP based on what destination IP tries to communicate to. So in this scenario, we create a loopback 0 on R2 just to make the second destination available. So under R2, okay, and to make sure R1 knows how to get to that, okay, ping. Okay, good. So here, what we're going to try to do is translate switch 1 loopback interface to 1.32 if it tries to talk to 1111, or we translate it to .33 if it tries to talk to 3333. So the way to do that is by access list. We call it to des1 permit IP host. We're just going to do a one-to-one static NAT here. So that's why we're using a host just to define one IP, and also going to 111 in particular. Next, we'll define the second access list to DST2 permit IP host, same IP. Going to 3.3.3.3. Next, we're going to tie that to a route map. Use the same name. Match the access list. So 2 separate route maps. Now we're going to tie it back to our NAT command. Insight, source, static, 172.16.32.32, 111.32. Here we can tie our route map to the command to DST1 and do the second one as well. Okay. Now if you go to switch 1 and telnet to 1.1.1.1 source loopback 0, maybe in R2 and do who. Let's see if we forgot to do something. Okay, looks like we forgot to remove that. So let's do that from our previous and delete the entry as well. And let's try that again. And you can see this time it used the IP 1.32 We show access list, and you can see to desk 1 was hit. Okay. Exit. Let's try again, this time using the R2 loopback interface. Okay, now you can see it's been added to a .33. And as expected, the access list was hit. Okay, it shows right here with the 2 telnet session that we had. And since we're doing static NAT, the switch 1 loopback should be able to be accessed by the R2. So we can try to ping 111.32. But let's try to ping 111.33. Okay, it's working as well. So the telnet so it's working no problem. And if you telnet to the .33 sourcing from loopback 1, that's working as well. Okay, so that should wrap up our basic NAT video. We still have an advanced NAT video coming up, so see you guys in the next video. And as always, thank you for watching LabMinutes.com.